I've got Vlad's correct by construction Casper running on Ubuntu here, and this is an important place to stop. It's the config file. Just to let you know what we're running here, I chose 3 validators, although the default was 5. I think 3 makes things clearer, just like we saw with Chris's example. The number of rounds is, you can go on for as long as you want, and so it's just, you set it at a high value. We're going to see charts that correspond to what we were seeing on the whiteboard, and the default report interval is 20. So in other words, you'd get a chart for every new addition to the whiteboard. So I've got it just set to 1 so that we can see every step along the way. So let's fire this thing up.
Right, so there we see the Genesis block. Each of the 3 validators has one. Here we see that the first validator sees its own Genesis block and, oh, I'm sorry, that's not the Genesis block. These were actual messages that were created, one by each of the validators. So from this, we can deduce that C must have sent it over to 1, because 1 is using it as part of its justification. We also see that 1 knows about its own justification, and the weights aren't displayed on here, but it must have thought that its own weight was more than C's. And so this is the chain that A sees. This is the chain that B sees, and this is the chain that C sees. Now, B produces a block. Because it uses this one, it must have seen this first block from C, but it must not have seen this one because this one weighed more, right? So we know that it saw this block from C. So C managed to transmit its block to both A and B by the time B produced its next one. I don't know. It should have, if I understood it correctly. Maybe. I think in Vlad's code he doesn't explicitly put in dashed lines for the ones on their own. And because this one was previous block pointer, that's why we see it. But this one, of course, it's going to include that one, so he doesn't add the dashed line. Yeah. Now, B produces another block, but it says, oh, now I have seen this block from A, and clearly this one weighed more than this one that I originally thought was the chain, so I'm going to switch my idea of where the chain is and switch over to A. Now, A produces a new block. It must have seen this one because it uses it as part of its justification, and it automatically includes this one, so it's not drawn. Similarly, same thing happens there. And now we're starting to get something involving an oracle that I don't understand yet. Does anyone know what those yellow squares mean? Have they?
Yeah, the color, the darker the color, the lower the probability is that the chain will not include those blocks in the future. So the idea is that these orange-colored blocks have safety, right there, or some weaker version.
So
of
this
safety.
is A's estimate of how safe this is. Is that right?
I think it's a global estimate. Like like the code itself sits back and goes, let's look at this. What's probably going to happen in the future? These two can't. I'm not 100% sure on that, but I don't think it's from the perspective of a particular validator.
Okay.
Right, because at that point in time, as the 2 in the left-hand column comes, because all 3 nodes have participated, you know that those are irrevocable, right? Because everybody has participated in the judgment that those 2 are the root.
That sounds about right.
So I just have one. What's the significance of the number in the block?
So it starts at 0 and then goes 1 and 2 as you go up.
Okay. Per node.
Yes. Now we see the ones on the left are darker. Apparently the system is judging them more secure, closer to finality. B is producing a new block. It hasn't seen the one from A yet. So it uses the one from C and says, I think it ought to be this. It knew about A0 and 1, but not A2.
Otherwise, it would have connected to A2.
I don't know that there's more to say, but it
Et cetera.
continues that.
Why do we know everybody has seen that one?
Well, we know that A has seen C2 because of the justification. We don't know whether or not B has seen C2, but that in this particular picture doesn't entirely matter. Basically, we know A has seen everything that's gone on and said, this is where the next block needs to go.
If consensus is 2, then you have consensus because 2 of the 3 have agreed that A2 is the root node.
But that's not the way it works in this system. It's always the tree with the chain with the most weight. So the weights have now appeared on the bottom there, right? So A is weight 95. So basically, whenever A makes a new block, almost certainly it's going to get included because it's double the weight of the other two.
You can mitigate a lot of that with that apparatus while still composing it with what's going on here. Yeah.
And we didn't get into that in this session because Vlad is not yet convinced of that proposition.
Yeah. So Vlad uses just like a weight function to assign a certain, whatever weight to given validators. He didn't really go into how he did that, but
I can tell you what it does in the Python code. It's a random number, Gaussian around 40, I think. So 95 is actually a pretty unlikely value, and we would expect them to be near 40. But like, the point is that Vlad never focused on where the weights come from. It's just weights exist, and we use them.
yeah. And so what you're saying is that in addition to possibly a weight function to provide a metric on the validators, they would have an additional form of capital that would be represented in a similar fashion and play like a similar influence on which path we took.
Right, so Vlad is saying this comes as input from stake, right? And what we're saying is, what I was saying is you can make the political capital be a function of stake, and then it sloshes around, and there'd probably be a lot more palatable to validators if that's a separate token that sloshes around rather than their actual stake.
Yeah, one of the things that we did get Vlad's clarity on was that in a block, you will never have more than the number of justifications in a block will never be more than the number of validators in this particular instance of the Casper protocol. And so that puts bounds on the size of the blocks that you need to send over the wire. So that was important for Chris to...
Okay. I was asking if the number of validators could always increase, and therefore you'd have an potential unlimited number of validators inside of a block.
Certainly not within a consensus round, and more generally not within an epoch, right? So when we're saying an epoch is when you get a validator rollover.
So the code doesn't have to be run in this interactive mode. You can set it up to output you a nice GIF of the images, and you can set your run to however many you want to see. So anyone who's interested in playing with the code can definitely do that.
So is this showing one consensus round?
Well, so this is why I think that this particular version of the model isn't entirely commensurate with the picture of RChain that people have in their minds, right? In this model, this is the blockchain. This isn't a consensus round, right? This is what the blockchain looks like.
Oh, okay, then
So, but like, and Vlad will confirm this as well, that this is a stripped down, simplified thing that just shows, it's an example of Casper's framework. It's not how Casper in RChain will work.
So in particular, in this drawing, there are no rounds, there are no epochs. It's just one continuous thing, and as these get darker, they get closer and closer to finalization.
In order to make this slightly more realistic, you have to be able to rotate the validators. Right. Eventually, validators are going to say, "I'm cashing out," or they fail or whatever, and new validators need to come in. So that's yeah.
What goes in the chain, right? This, again, these blocks are sort of abstract things that don't actually carry any data, right? The other realistic thing is that they have to carry transactions associated with them, and that's why we have consensus rounds that eventually publish a consensus or finalized set of transactions to the blockchain itself, right? The consensus and the blockchain are almost more decoupled in the RChain picture than in this picture.